So this is the third lesson of advanced trigonometry, where we're going to be using the sine rule to find missing angles in a non-right angle triangle, okay? So let's jump right in. So before we use the sine rule to solve some questions, let's actually have a look at how the sine rule works, okay? So this is a proof for the sine rule to find missing lengths and angles, okay? So first, let's remind ourselves of the convention of labeling sides and angles of triangles, okay? So if we've got a triangle and it's got three angles inside it, we would label the sides in lowercase letters, so lowercase a, b, and c, and the angles opposite those sides would be the capital version of those letters, okay? So angle A is opposite side A, angle B is opposite side B, and angle C is opposite side C. Okay, so for the sine proof, we don't actually need side or angle C. Okay, so we should all know when we use the trigonometric functions sine, cos, and tan, we can only use these with right angle triangles. Okay, or so we think. So with this non-right angle triangle, we need to find a way to split this into two right angle triangles. Okay. And one way of doing that is just drawing a line from the highest point of the triangle to the lowest point of the triangle, a straight line down, okay? So now we have a line here. We're going to call this H for height, okay? So now we've drawn this height line, we can actually split this triangle into two separate triangles, okay? So we've got a purple side and we've got an orange salmon-y color other triangle, okay? Now, we know if we label up these triangles, so for the pink one, we've got angle A, like the big triangle over here, and we've got side B and we've got side H, okay? And for the orangey triangle, we have got angle B, we've got side A and side H, okay? Now we're dealing with right angles, so we know we're going to use a trigonometric function of some sort, okay? So for both of these triangles, for the angle, we either know or would be trying to find the opposite side of the triangle and the hypotenuse of the triangle, okay? So we're looking for the trigonometric function where we use the opposite and the hypotenuse of a triangle, okay? And the hint is in the name of this rule, it's the sine rule, so we're going to be using the sine function, okay? And to remember, just to remind yourselves of the sine rule, so sine of an angle is equal to the opposite side over the hypotenuse side of a right angle triangle, okay? So let's use this formula, but with these triangles, okay? So for the purple triangle, I've got sine. The only angle I've got is angle A. So sine of A is equal to the opposite over hypotenuse. Well, in this case, the height is the opposite side, and the hypotenuse is side B, okay? Now, I want to rearrange this equation, so I've got height on its own, okay? And because I'm dividing by height, I'm going to want to multiply both sides by B, and that will leave me with B sine A equals H, okay? Now let's do the same for the second triangle now. So again, I'm going to do sine. The angle is B, and that's going to be equal to the opposite over the hypotenuse. Now in this case, the height is the opposite again, but this time side A is the hypotenuse, okay? Now I want to rearrange this equation to get H on its own. So I'm going to have to multiply both sides by A to cancel out this A. So that leaves me with A sine B is equal to height. What you should notice now is that we have now got two equations that are both equal to the same thing. So now we've got B sine angle A is equal to height. We've also got A sine B is equal to height. So because they're equal to the same thing, we can now put these two things equal to each other, okay? So let's just do that. So over here now, I'm going to do A sine of angle B is equal to B of sine A. Okay, So this is right, because they were both equal to h, we can put them both equal to each other, okay? Now, what I'm going to do is to divide both sides of this equation by sine angle A and sine angle B, okay? So I'm just going to divide both these sides by sine A and sine B, okay? Now, you should notice for the first part of this equation, we've got sine B in the top and bottom of the fraction, okay? So we can cancel that out. And for the second part, we've got sine A in both the top and bottom part of the fraction, so we can cancel those out as well, okay? So that leaves us with A over sine of angle A is equal to B over sine of angle B, okay? And if you rotated this triangle around and you did the same thing, but we included side C, you would also find that C over sine C would also be equal to all of these, okay? So this is the sine rule for finding missing lengths and angles in non-right angle triangles, okay? So let's use this formula to answer some questions. Okay, let's have a look at a few examples. But before we do this, when we're solving for missing lengths, we use this formula up here, okay? So this is for lengths, okay? Now, to make this lesson slightly easier for us, to find missing angles, we're going to make a very, very small adjustment to this equation, okay? So instead of the side being over sine of the angle, we're simply going to rewrite the formula so it's sine of the angle over the side length, okay? So sine B over B, which will be equal to sine C over C, okay? And this is totally fine. We're allowed to do this in math, so we can flip this over. And you'll see when we do the examples, it's much easier to solve these equations when we've written out our sine rule like this. Okay, so let's change the formula at the top of the screen. Let's get rid of all this. Let's change the formula. There we go. So this is what we're going to be using to find missing angles to use the sine rule. Okay, so let's have a look at our first triangle. So we're looking to find angle X. Okay, so there's our angle X. So first things first, let's label up this triangle. Okay, so this is angle A, this is side A, that's angle B, and this is side B. Okay, so let's fill in the formula. So we've got sine of angle A over A, sine, well, angle A is X, and side A is 8, and that's going to be equal to sine B over B. So B is the angle B is 44. So sine 44 over length B is 14. Okay. Now I need to rearrange this left side of the equation. So I've got sine X on its own. Okay. So I need to get rid of this 8. And the way I'm going to do that is I'm going to multiply both sides by 8. Okay. So that leaves me with sine X is equal to 8 times sine 44 over 14. Okay. Now the final step to solving for X now, we need to do the opposite of sine. And hopefully you remember the opposite of sine is the inverse sine function. Okay, so X is equal to inverse sine, which is sine minus 1. Okay, so you have to press shift then sine on your calculator to get this. Okay, and then in the brackets, we're going to write 8 times sine 44 over 14. Now, some of you might be wondering, why haven't I solved for 8 times sine 44 over 14? Well, the reason is, if you when we deal with trigonometric functions, if you are out by even 100th or 1,000th of a decimal, you will not get the right answer to a question. Okay, so as long as you type in inverse of sine of 8 times sine 44 over 14, you will guaranteed get the right answer. But if you find the answer to 8 times sine 44 over 14, and then you round that number to even 4 or 5 decimal places, there's a chance you may get the question wrong, okay? So that's why in our calculators, we type in all the numbers without pressing the equal sign at all, okay? We only press equals once we've written in sine -1 brackets 8 times sine 44 over 14, okay? So don't solve what's in the bracket first, okay? Make sure you type all this in your calculator, okay? And then once you press equals in your calculator, you should find that for this question, x is equal to 23.39 degrees, okay? Let's have a look at another example. So again, we've got a triangle. We're trying to find the missing angle x. So first things first, just going to label up this triangle. So angle A, side A, angle B, side B. Okay, I'm going to use the formula. So sine angle A was x, and side A was 11. And that's going to be equal to sine angle B was 42, and side B was 8. Okay. I need to rearrange to get sine x on its own. So we need to get rid of this 11. I'm going to do that by multiplying both sides by 11. So that leaves me with sine x is equal to 11 times sine 42 over 8. And remember, now the final step, we've got sine of x equals this. The final step is to do the inverse of sine, but we don't solve for what is on the other side of the equation. We don't solve 11 times sine 42 over 8. We have to make sure we write sine, inverse sine. In the brackets, we write 11 times sine 42 over 8, okay? And that will make sure you've got the correct answer, okay? And if you press equals on the calculator, you should get 66.93 degrees, okay? So that's our final answer for x, okay? So we're going to do one more example, and it's ever so slightly different to the last two examples, okay? So let's have a look. So one more triangle. So let's label up the sides first. So I'm going to call x angle A. Therefore, that will be side A. 27 degrees will be angle B, and the opposite side will be side B. Okay, so we've labeled our triangle lovely. So sine A, angle A was x, remember? Side A was 10. Okay, and then sine B, well, angle B was 27. So sine 27, and side B was length of 5. Okay, so let's rearrange the equation. I want to get rid of this 10 on the left-hand side, so I'm going to multiply both sides by 10. So that leaves me with sine x equals 10 times sine 27 over 5. Okay, and then the final step, we've got sine of x here, so we need to do inverse sine. So x equals sine minus 1, or inverse sine, 10 times sine 27 over 5. Okay, so if you type down your calculator and you press equals, you should get that x equals 65.23 degrees. But hang on a minute, I'm not sure that I'm entirely happy with this answer, okay? Because if we actually look at angle x, I can see that it is actually bigger than 90 degrees, okay? Very crude drawing, but I can actually see that this angle is much bigger than 90 degrees, okay? So what's going on? Well, for sine of this number, 10 times sine 27 over 5, there's actually two possible answers. So if you think about it, we could redraw this triangle. If I was to extend this, draw that there, I could have, this line could be 5 centimeters, and this angle could also be x, okay? We'll call that y instead, okay? So we've got two lines that are 5 centimeters coming from a corner that has an angle of 27 degrees and a length of 10 centimeters up here. But we've got two different lengths. So therefore we've got two different possible angles inside here, okay? So when you're dealing with an obtuse angle, so this is only for obtuse angles. and those are angles that are bigger than 90 degrees, okay, we need to do 180 take away this number, okay? So we need to do 180 take away 65.23 degrees. And if you just solve that in your calculator, you should get 114.77 degrees, okay? So actually x equals 114.77 degrees. Okay, because this angle we found here, 65.23, this is the angle if it was an acute angle, okay, or an angle less than 90 degrees, okay? But because the question, the angle x was bigger than 90 degrees, you have to take this answer away from 180, and that will give you the true answer for x. Okay, so just be very careful when you're looking at this. Make sure, just glance for 2 seconds to see if the angle you're trying to find is an acute angle, which is less than 90 degrees, or an obtuse angle, which is bigger than 90 degrees. Okay, so let's have a go at some questions then. So pause the video and have a go at these questions, please. Okay, here are the answers. Very well done if you got them right. And for these questions, E and F, if you didn't get these numbers, try and take your answer away from 180. And if you got the right answer, then well done, but you just missed out the final last step. Okay, so because these two questions, x was an obtuse angle, you have to take whatever you found for x following the original method away from 180, and that would give you the value of x because it's an obtuse angle. Okay, so very well done if you got those. Checking question now. So pause the video and have a go at this question, okay? See if you can remember the formula off the top of your head, okay? Best of luck. Okay, so let's go through the answers. So hopefully we all remembered by now the formula is sine of A over side A is equal to sine of B over side B, okay? So if we label up this triangle, I'm going to call Y angle A, therefore 21 will be side A, 84 degrees will be angle B, and 32.4 centimeters will be side B, okay? Substitute the values into this formula. So sine of Y over 21 is equal to sine of 84 over 32.4. Now to get sine y on its own, I have to multiply both sides by 21. That leaves me with sine y. So that leaves me with sine y is equal to 21 times sine 84 over 32.4. Now I'm going to do the inverse of sine, or the opposite of sine, which is sine minus 1, or inverse sine. So therefore y is going to be equal inverse sine, brackets 21 times sine 84 over 32.4. And if you pressed equal on your calculator with all that typed in, you should have got that y equals 40.14 degrees. Okay, so very well done if you got that right, and I'll see you next lesson. Bye now.